Dear learners, greetings. In the last part of this phenol, we are going to discuss about the tests for phenol. So at the end of this session or at the end of this lecture, you will be able to perform the tests for phenol. One is the ferric chloride test. Another one is the Lieberman nitroso test. These are the different color tests that I'm going to explain you later on. So you will be able to understand what is the azodide test and the Thalaline test, and the various derivatives of phenol will give different colors for these different tests. So at the end of this session, you will be able to understand the principle behind the different tests of phenol, that is the qualitative identification estimation of phenol. Now the first test is the ferric chloride test. So what is this ferric chloride test? In this ferric chloride test, the phenol is going to react with the ferric chloride and you will get this violet color complex of your phenoxide ion and the FeCl2. Actually, when this ferric chloride is reacting with the phenol, the total number of phenols used are 6. That is the 6 phenoxide. Check here, 6 phenoxide and one ion. Ion is 3 plus. This phenoxide 3 minus. So what is remaining? 3 minus. Why? 6 phenoxide, 6 minus. 3 Fe, 3 plus. So here it is coming as a 3 minus. Isn't it? 3 minus. And 3 protons are the byproducts. Got that? So ferric chloride, when reacted with the phenol, the violet color complex is happening. How this is happening? See here, in the middle it is iron, isn't it? In the middle it is iron, Fe3, ferric, and then 1, 2, 3, 4, 5, and 6. So these 6 phenoxide will get attached to it in this format. In this format. Got that? And 3 HCl and 3 protons are released. And you will be confirming the violet coloration. If it is coming as a violet coloration, it is the violet color complex of ferric chloride with the phenol. So that is what the ferric chloride violet color test. Now here I have mentioned the things, that is, if there is a presence of phenol, you will get either green or blue or violet coloration. If it is there is a presence of alpha naphthol phenol derivative, you are going to get the white to violet precipitation. So that means if it is white or violet precipitation, you can say the compound may be alpha naphthol. In case of beta naphthol, it is green to white precipitation. In case of resorcinol, it is bluish to white precipitation. In case of hydroquinone, it is having the greenish black precipitation, and the presence of pyrogalol, you will have the red precipitate. So these are the identification of phenolic group in these different derivatives of phenol. Means alpha naphthol, beta naphthol, resorcinol, hydroquinol, pyrogalol. These are the derivatives of phenol. These are the different phenols. And how we are going to identify qualitatively, that is when the sample is dissolved in water methanol, and if you add few drops of ferric chloride in it, you will get this different coloration, these different color precipitates. So once you see the visually see the these colors, you can simply identify this compound is phenol, alpha naphthol, beta naphthol, resorcinol, like that. Understand? Now second important test is the Lieberman nitroso reaction. Many a time this reaction is asked in the examination. So this is the phenol. Okay, so phenol when reacted with the sodium nitrite NaNO2, understand, then the red coloration is formed, and with the excess of sodium hydroxide, blue coloration is formed. What is happening? Phenol reacted with the sodium nitrate NaNO2 in the dilute sulfuric acid. What is happening? See, this OH is as it is, this OH, and NaNO2, this NO part is attaching at the para position, and then this hydrogen shifts here, it forms NOH, and here keto group. So in acidic media, what is happening? The H2SO4 will provide one proton here. So what it form? NOH2. Now you know that what will happen? From here, one water molecule will be released. OH2 will be released. You will get this double bond O, double bond N. And when this nitroso, when reacted with the phenol, you will get this addition compound, this phenol and this one, nitroso. So what will happen? This OH, this benzene, that is your phenol. Then this nitrogen is going to get attached to the para position and the remaining compound, nitroso compound. So this compound is actually the red coloration, which is the indophenol. And with the, when you add that is aqueous potassium hydroxide, potassium salt is formed. The difference is here it is OH and here it is OK, potassium. Okay, and this is the indophenol, which is blue in color. Means what I told you, that is in excess of basic, it will turn into the blue coloration, and in the excess of water, that is a dilute sulfuric acid, the plain, we are going to get the red coloration of the indophenol. So this is the Lieberman nitroso reaction. Now here you can see how this test is performed. This test is performed, that is what, heat sodium nitrate crystals and sample for 1 minute, and then what is done? Cool and add 1 ml of sulfuric acid and shake. So what is going to happen? Phenol presence, when the phenol is present, green to blue coloration is coming, and dilution in with water, that is dilute sulfuric acid, you will get the red coloration, and basification, that is excess of potassium hydroxide or sodium hydroxide, will give you the its original color. Got that? Then orthocresol, metacresol, resorzinol, catechol, what is the color formation? Deep blue or green coloration. Paracresol, it's a brown coloration. Then alpha naphthol and beta naphthol, it will give green color or black color. So by finding or by observing these different colors, you can say whether which is that particular phenol is. This is all you are supposed to write this test, and many times in the MCQ this is asked. So green color, what it is, the brown color, what it is. So the derivatives of phenol and Lieberman nitroso test, which color it is going to give, that you have to identify. And now see another test, that is the azo test. In case of azo test, what is happening? Your aniline, when reacted with the sodium nitrate in acidic media, you will get the benzene diazonium chloride, and benzene, this is benzene, diazo, this two nitrogen, and chlorine, benzene diazonium chloride. And when this benzene diazonium chloride is reacted with the phenol, the coupling reaction takes place. That is what? It is coupled. How it is coupled? See, benzene as it is, these two nitrogens as it is, and to this phenol at the para position, this para position, this is going to get attached. So this is para hydroxy azobenzene. Got that? This is the coupling reaction in alkaline media. Generally, this azo dyes are formed. See, this is the color of azo dye. This is the color of azo dye. Okay, so by seeing this color, by identifying or observing this color, we can say this is the azo dye formation. So how it is done? It's simple. Check how it is done. What is done? See here the azo dye formation. How it is done? Simple. That is dissolve. What the aniline is taken. Okay, in the concentrated HCl. In that you add few drops of few ml of water. Shake to dissolve any hydrochloride. which may have separated and cooled in ice. Okay, then add few drops of, that is the sodium nitrite solution. Add this cold isonium salt. So whichever this, after mixing this, you are getting the disonium salt, isn't it? Aniline, hydrochloric acid, water, and this you cool it, and after that you will add sodium nitrate solution 20%. Understand? And this cold disonium solution on a cold solution of phenol. When you add it and in then excess amount of sodium hydroxide, what will happen? The, I told you, that is solution or precipitate of azo dye, which is the color, orange coloration will be formed, and that will indicate that there is the presence of phenol. So the same practically will perform in the lab as well, and this is the test and this is the principle. So principal reaction, then what is the observation, what is the test, that you have to remember. The next test is Thalaline dye test. Thalaline dye test, again, it's a very simple test. First understand the reaction behind it. Phenol, it is going to get react with the phthalic anhydride, CO and O. Understand? In presence of sulfuric acid, the phenolphthalein is formed. Phenolphthalein. Check this. This is the condensation. Two phenol molecules, two phenols are taken. One phthalic anhydride is taken. You will get the colorless phenolphthalein. To this phenolphthalein, if sodium hydroxide is added, you know that now it is turning basic. So what will happen? The ring structure. See, this ring structure is broken and you will get the pink coloration at 8 to 10 pH. And when excess of sodium hydroxide is added, it will, that is what, it will change the pH above 11. In that case, it will turn into colorless. So this is the Thalaline dye test. That is simple. Phthalic, the phenolphthalein test. That is phenol plus phthalic anhydride, you will get phenolphthalein. If there is formation of phenolphthalein, what it gives, that is a color change in, when it turns from acidic to basic, it will give you the color change. So when sodium hydroxide is added, pink coloration, red coloration will come. So that indicates it's a phenolphthalein is there. Got that? Phenolphthalein is there means what? Phenol is there in the compound which you have to identify. Got that? So this is the Thalaline test. So how it is done? You know this test. Now what is done? That is phenol plus phthalic anhydride. Understand? And in that you will add sulfuric acid. Okay, heat it and then add 10% of sodium hydroxide. If the compound is having the phenol or orthocresol, it will give the red coloration. If it is the metacresol or pyrogalol, it will give the blue coloration. For resorzinol, the yellowish red green fluorescence will come. In case of alpha naphthol, green coloration will come. And in case of beta naphthol, the faint green coloration with the fluorescence is coming. So you have to you have to remember. For orthocresol, red coloration. For pyrogalol, blue coloration. Resorzinol, green fluorescence is there. Alpha naphthol, green coloration. Faint green with fluorescence, it's a beta naphthol. So these are the various tests you have to remember. So these are the various derivatives of the phenol. This you have to remember the structure, that is a phenol, that is your benzene and OH group. Various uses we have already discussed. In case of cresol, that is the OH group is there and the methyl group at the ortho, it is orthocresol. Methyl group at the metacresol. Methyl group at the para, it's a paracresol. Okay, I have just put few of the usage, you just go through it. Similarly, resorzinol, instead of one OH, the OH group, the two OH groups are there and they are one carbon away. So that would be the resorzinol. Just go through the different usage of it. And naphthalene is what? Two benzene ring attached to each other. That is naphthalene. And to this naphthalene, one OH group is there. So that is the naphthol. So this is one naphthol or alpha naphthol. And this is beta naphthol. At the first position, alpha naphthol. Second position, it is beta naphthol. And these are the certain usage of the compound. Understand? So in short, what we had discussed in the entire phenol, that is the different methods of preparation of phenol, different reactions of the phenol, then different tests for the phenol, then what is the basic chemistry of phenol, what is the importance of phenol, what are the important usage of phenols and their derivatives, and that of the basic chemistry of phenol, how the phenol is acidic in nature, why it is acidic in nature, why it is more acidic compared to alcohol. That all we had discussed in the entire phenol chapter. So this is all about the phenol. In the same way, you can go through the notes for amines and carboxylic acid. So the carboxylic acids and amines notes are attached in the Moodle. You can go through the notes of phenol as well, amines also, and the carboxylic acid. So this is the end of chapter number or the unit number 2. Thank you.